Today, I will review a unique kind of laser engraver upgrade, the Atomstack MR20, a true fiber laser upgrade kit for Atomstack laser engravers. It produces invisible laser light with 1064 nanometer wavelength light, which will allow you to make deep engravings on all types of metal. The kit includes a true 20-watt fiber laser source and a laser head. You also get a new control board, fine focus adjustment upgrade, and all the needed accessories and cables. The laser head is permanently connected to the laser source with an optical fiber. The cable is durable and flexible. The laser module is very well made. It has two red laser pointers on the side, which are used for finding the optimal focus, as we will see later. I will mount this upgrade kit on the Atomstack Maker X30 Pro, which I have tested in one of my previous videos. The kit can be mounted on a majority of the Atomstack laser engravers. The installation of the MR20 fiber laser upgrade kit is simple. First, you need to install the fine focus adjuster. Then you remove the old control board and all the wiring and install the new one. The upgrade kit is designed so that you will be able to switch between the blue diode and fiber laser with ease. When you want to use blue laser diode, you need to connect these two wires together. When using the fiber laser, you disconnect them and connect the additional wire which goes to the laser module. The thing that bothers me is that the additional wire harness is not well thought out and looks like a quick fix. The USB connector attaches to the fiber laser source, and the other side goes to the laser module directly. The cable management is poor, and the harness might even get in the way of the laser beam if you are not careful. With the kit, you get very cheap safety glasses, which I don't trust for this laser source as it produces invisible laser light of very high intensity. This is why I use these laser safety glasses, which provide at least 10 times better protection for your eyes. You will find a link to them in the video description. Focusing the module is easy. Quick focus adjustment is done by releasing two thumb screws. The focus is perfectly adjusted when two red dots align on the surface. Then you can fine-tune the focus with the fine focus adjustment screw. The red laser beam is also very handy for framing your work area. Now let's engrave some anodized aluminum. When engraving metal, fume extraction is also very important. With this button, the pulse frequency can be adjusted from 30 to 60 kHz, which changes the engraving effect. We will test this effect later. I am running my standard test pattern on anodized aluminum to measure the focus spot size and test how well it performs at small text engraving. And these squares are engraved at different speeds ranging from 100 to 10,000 millimeters per second to see how the speed affects the engraving performance. The interval test is used to measure the laser spot size and shape by filling the shapes in vertical and horizontal directions, with each shape having different fill density. I also engraved a hamster to see how well it performs with a more practical engraving task. Looking at the results, we can see that the laser beam is very thin and is able to produce very small details. The only problem is that my frame lacks mechanical precision, and because the laser spot size is very small, this is much more noticeable. If we compare the results to the same test done with a blue laser module on the same frame, we can clearly see the difference. Looking at the squares engraved with different speeds, we can see that the speed doesn't have a big effect on the engraving brightness like it has with blue laser modules. Fiber lasers are capable of engraving at very high speeds. Looking at the interval test, we can see that the laser spot size is approximately 0.05 millimeters. But because the machine lacks mechanical stability, the lines are unevenly spaced, which will cause problems when trying to do consistent fills. When looking at the engraving of a hamster, the mechanical precision issue is even more present. In this case, I shouldn't have traced the outlines of the vectors. With the big laser spot that a blue laser module produces, we wouldn't notice these problems. But with the thin laser beam of the Atomstack MR20, the issue is clearly visible. This effect can be corrected by enabling scanning offset in the Lightburn software. I experimented a bit with the settings until I was able to produce better engraving results. Next, I went to see how well the laser module retains its focus further away from its optimal focus distance. First, I engraved a square at optimal focus. Then, I removed one 3mm thick acrylic board from underneath and engraved it again without readjusting the focus. The engraving was much weaker than before, so I increased the power and engraved it again. I tried again with full power. Then I removed another 3mm plate, and the laser was barely able to engrave the text, as it is not meant to work at such high amount of defocus. You can use defocus to your advantage. I have engraved this hamster at 3mm defocus, and the engraving came out much nicer thanks to the larger focus spot size. If we look at the results under the microscope, we can see that the laser spot size is still relatively small at 3mm, and the engraving of the hamster looks perfect. Next, I engraved my logo on a 0.5mm thick stainless steel plate at full power, and the MR20 engraver was powerful enough for the text to stick out at the other side of the plate because the steel warps due to the heat. Next, I did some experiments on raw aluminum to see the effects of the frequency settings. First, I engraved with 30 kHz, which is the lowest frequency setting. The second time I tried with 60 kHz, and with this setting, the beam was not marking the surface. Only when I decreased the frequency to around 45 kHz did the beam start marking the surface again. The frequency parameter doesn't produce vastly different results on raw aluminum. The higher frequency reduces the energy of the individual laser pulses, allowing you to engrave more delicate materials like plastics. Then I tried engraving raw aluminum with the recommended settings that come in the manual. The result came out quite well, but it isn't dark like pictured in the manual. It is important to note that it is almost impossible to make dark engravings on aluminum. Now let's see how well the Atomstack MR20 performs at laser cutting. First, I tried to cut 0.5mm thick aluminum plate, but it didn't go through. It has left a very deep engraving that is visible from the other side of the plate, but the letters didn't pop out. Then I tried to cut a 0.2mm thick titanium sheet, and it went through in the first pass. Cutting titanium and stainless steel will leave discolored edges since the metal changes color when heated. But cutting thin aluminum like this metal business card will leave a nice and clean edge because aluminum doesn't get discolored due to the heat. For fun, I tried to cut a 1.5mm thick brass plate to show you what are the problems when trying to cut thicker stuff. I have let it run for 50 passes with slow speed and full power. As we have seen earlier, a fiber laser produces a very thin laser beam, which has very high energy density which melts the metal easily. But because the beam is very thin, the molten metal melts back together behind the beam as the gap is very small. Because of that, the deeper you cut, the more noticeable this effect becomes. With galvo fiber lasers, this effect can be mitigated by enabling beam wobble parameter, which runs the beam in very small circles, which produce wider cut. But with a gantry machine, this is very difficult to do as it is not as precise or fast as the galvo system. Looking at the result, we can see that the engraving is sticking out of the surface instead of being recessed. With each pass, the molten brass was welding back together. This is why it was unable to cut through. This laser module is great for engraving stainless steel. It produces much thinner lines and can engrave much faster. Here you can see how it compares to blue diode lasers. The important thing to know is that blue lasers can't engrave brass, copper, or aluminum at all, but this module can. Fiber lasers are also great for engraving on black acrylic. Fiber laser will produce white engravings which are deep, very durable, and look great. Lastly, I wanted to give the Atomstack MR20 another chance at laser cutting. First, I tried to cut a 0.2 millimeter thick feeler gauge at 300 millimeters per minute. The cutting progress was slow, and it was able to cut through in around 30 passes. Then I tried again with a much higher speed of 1500 millimeters per minute, and despite needing more passes, the overall duration of cutting time was significantly lower. Thanks to its long focus distance, it can effectively remove it from more textured surfaces too. Since it can mark all types of metal, it is a great machine for marking tools and other belongings. It also works great on stone. It leaves a good-looking white engraving, which is slightly brighter compared to blue diode lasers. Compared to galvo fiber lasers, this machine struggles a bit with more delicate engravings on some plastics. Because it is a gantry machine, it is slower and therefore it is more difficult to control the depth of engraving in some plastics as it can quickly melt. I tried a few different power and frequency settings, but I didn't find the perfect combination for this type of plastic. Thanks to the tightly focused beam, this machine can produce very intricate engravings on this anodized aluminum keychain. In conclusion, the Atomstack MR20 is a unique type of laser engraver attachment. It can expand the usability of your diode laser engraver. Compared to galvo fiber lasers, it has some weaknesses as it lacks the speed and precision, but it can make up for that by providing you a much larger work area. It also costs less than buying a separate galvo fiber laser.